Hi everyone, welcome back to the channel. My name is Emmanuel, and on this channel, we learn DevOps through practical projects and real-world examples. In today's video, I will show you how to deploy a Node.js application using Docker. Let's dive right in. So what will you learn before the end of this video? You learn what Docker is, why containers are useful for deploying application, how to create a Docker file, how to build a Docker image, and how to run our Node.js application inside a container. So what is Docker? Think of Docker as a digital shipping container system for software. It is a tool that packages your application and everything it needs to run into a container. To understand why I describe Docker as a digital shipping container, let's picture how global trade was before the 1950s. Back then, shipping was done via a method called brick bulk shipping, and that created a lot of logistical headache. Let's look at the problem associated with the brick bulk shipping. Before containers, if a factory in Ohio wanted to ship goods to a store in London, the first challenge they would encounter is what we call the chaos of ships. So let's understand what this chaos of ship means. Now, because a factory is not the only one shipping goods, they are going to have a cargo that isn't uniform. So this cargo may consist of barrels of whiskey, some sacks of flour, some crates of shoes, some loose lumber, and some unboxed machinery. Now, when a ship arrives at the harbor, we will have hundreds of dock workers to manually pack thousands of these random mismatched items into the hold of the ship by hand. This was very slow and agonizing. Now, every time the cargo changed transport type, so for instance, it is changing from a ship to a train, this nightmare repeated. The worker had to unload the cargo ship piece by piece. How and then load it on the train piece by piece. And so all of these items will be moved piece by piece onto the train. Now the consequence is that ships are going to spend more time sitting idle at the docks being loaded and unloaded than they actually sailing. And also, because the goods were handled so many times, theft was rampant, items were consistently broken, and were ruined by some weather conditions. So how do we solve the issue where all of these items that are not uniform need to be moved piece by piece, piled, and then moved onto another transportation system? And how do we prevent that? And how do we ensure that theft is minimal, the item that is being transported is not broken, or these items are not ruined by some weather condition because it needs to be piled and then moved onto another transport type? So how do we solve the challenge of moving this item piece by piece onto a train or a truck to be transported to the second or their destination? What if we can stop moving these goods piece by piece and instead just put everything into standard metal box called a container. Now, the ship will not care if it is carrying diamonds or manure. What the ship would see is a 20-foot metal box, and cranes can easily load into the ships in hours instead of weeks. Now, because everything is in a metal box called a container, theft is going to reduce drastically, cost is going to go down, and whatever unfavorable condition that was causing the loss of goods would go down because everything is inside the container, and this container is now moved onto the ship or a train or any other transport system that needs to take this ship or any other transport system that needs to take this cargo to their destination. Before Docker, software development looked exactly like the brick bulk shipping we've just described. Now imagine building a website. To get it running on a company server, you couldn't just send the website code. You had to send a chaotic mix of loose goods. So you have to send the code itself, a specific version of database, let's say MySQL 8.0, a specific helper library, let's say you're using Python, so you're going to have Python 3.9, some dozens of background settings and security certificates. Now, when this cargo arrived at the server, a system administrator had to manually install all of these pieces on the server. And just like the brick box shipping, it is often going to break. Why? Because the server might already have a different Python version installed, let's say Python 3.7, and that is being used by another application. So installing your version of Python, which is 3.9, will break everything that we have on the server. Also, your code can get corrupted. You can even miss some settings when you are moving the pieces bit by bit onto the server, and deployment is going to take days of manual stressful labor. So how do we solve this issue of break bulk in code? To solve this challenge, we use Docker. Now, Docker did what Malcolm McLean did for shipping. It said that stop trying to manually install all these loose pieces on the server, but instead put the code, the database, the Python version, the system settings, and everything that you need for the application to run inside a container. Now, the server doesn't care what language your application is written in or what setting it needs. What it just sees is a standard Docker container. So this Docker container is pushed onto the server. You click run and your app works perfectly on the server. Now we can still take this container and then deploy this container on a friend's machine, and the application is going to work perfectly. Why? Because everything that is needed has been put inside a box. So we just put the container on the friend's machine and run it, then our application starts. Currently, we know that Docker is a containerization tool. Now, containerization is packaging an app into a container. To do this, you follow a step-by-step workflow that takes your raw code and turns it into a Docker container that you can run on a server or on your local computer. So what are the steps to containerization? Step one is to write your application code. So first, you build your app just like you would normally would. At this stage, the app only works on your local computer. The next step is to create a Docker file, which is step two. Now, inside your project folder, you create a new file and name it exactly Docker file. No extension. Now, this Docker file is a plain text file where you write the step-by-step instructions for Docker to build your environment. The next step is to build an image from your Docker file. So now you would open your terminal or your command prompt, navigate to the folder and tell Docker to read your recipe, which is your Docker file, which contains the step-by-step instruction, and then build a frozen snapshot that we are calling an image. So you run a command and Docker would execute your Docker file line by line. So what's going to happen is that once you run that command here to build an image, Docker will execute your Docker file line by line. First, it's going to download a mini Linux system. Copy your files from your local computer onto it. Install all your libraries, all your dependencies, etc. And freeze everything in a single file that we are going to call an image. So now that you have your frozen image, you can bring it back to life. What you do is to tell Docker to run the image as a container. When the container runs, then you've containerized your application. So your app is officially containerized. This means that this application is isolated from everything that is on your computer. So the application lives in its own bubble inside your computer. We can now take this containerized application and run it anywhere. So this containerized application can be run on a production server and is going to work perfectly. This same containerized application can be run on a friend's computer and is going to run perfectly. So the application would work the same. Nothing would be broken. And you don't need to install dependencies or library piece by piece. Why? Because everything that you need has been frozen into an image. Now that you've learned some theory concerning Docker and containerization, let's go and deploy a Node.js application. I've already created an EC2 instance, so I'll log into the instance and then we'll get started. I've created an EC2 instance on AWS and connected to my server. Before installing anything, always update the server packages. So you run sudo apt then update. So this download the latest package information. Now you need to upgrade this installed packages. So once this is done, I need to upgrade it. This helps keep the server secure and then updated. So I'm going to run sudo apt upgrade and dash one. So I'll pause the recording at this session and resume when the upgrade has completed. Great. Now let's install Docker. So I'm going to run sudo apt install docker.io and then -y flag just to say yes to all the default, and then let's start the installation. Great. Now let's check if Docker is running. So sudo systemctl, and then want to check status of a service called Docker. All right, so we can see here that Docker is active. Now let's enable it so it can start automatically when the server reboots. So to do that, you need to run the command sudo systemctl enable Docker. Great. Now let's jump on to create the Node.js application. In this session, we are going to create the Node.js application. So what we need to do is to create our project folder or our project directory. So I'm going to do mk there, and then we're going to name our project Node.js Docker app. Okay, so let's cd into this directory. Right, so when we check ls, it's empty. There's nothing in that directory. So what we want to do is to initialize a Node.js project in that directory. So we run the command npm init and then a -y. This is going to create a package.json file in our project directory. All right, so we don't have npm installed on our server, so we need to do that installation. So you're just going to run sudo apt install npm, enter. Yes. So I'm going to pause my recording and then resume when the package has been installed successfully. Great. Now we have our package, our npm installed on our server, and so we can initialize our package.json. So init -y, enter, and this would create a package.json for us. So once we do ls, we'll see that there's a package.json, and the package, you see that there's a package.json. So basically this package.json keeps track of some tools or libraries that would need for the application to run successfully. Next, let's install Express on our server. We'll use Express to create a simple web application. To install Express, you run npm install Express and then enter. So now that we have Express on our server, we can proceed to create our application. The first thing that we'll do is to create the application file. And so I'm going to name my file app.js. So what I'm going to do is I'm going to do touch app.js. So when I do ls, I have the app.js in my directory. So it is from this app.js that I'm going to now write the application. Now, what is this application going to do? When someone make a request to the slash, we're just going to return a response that says hello from Docker. just to ensure that our application is running and it can be accessed from the browser. Let me run you through what is happening here. So first of all, we import Express into our file. Express would help us to create our web server. And from here, we define the endpoint, that is the URL that you need to hit from your browser for it to return a response to you. So this is the logic. Anytime somebody goes to a URL and then hits the slash, which is the home page, going to return a response that says hello from Docker. And then this Express server is listening for connection on a port. The port is 3000. While this connection is established, it's going to log this on our terminal. App is running on port 3000. Now let's test our application locally before using Docker. So to test the application, write node, then app.js. App.js is a file that contains our application. So once I click on enter, you should see app is running on port 3000, meaning that a connection has been established on our web server and our app is currently running. So to view the response from our application, I can open my browser and then visit my server IP and then specify the port. Remember that the server is listening on a particular port, which is 3000. Once we hit that port, then we should get hello from Docker being displayed on our browser. So let's test that. Great. So I've entered my server IP and then the corresponding ports, and then this is the response I'm getting from my application, meaning that our Node.js application is running locally. Now we can proceed to containerize this application. Now that we can confirm our application runs well locally, let's containerize this application. Now remember that we've created our Docker file inside our root directory or our project directory, which is our Node.js docker-app directory. And so we will need to run this Docker file to build an image. To do that, you run the command docker build -t Node.js -app and then version 1.0 in this current directory. All right, so let me run you through what this command is doing. The Docker build is a command that helps us to build our Docker image using the instructions that we've given in the Docker file. The -t is to tag this image, that's to give it a friendly name or a versioning for our image. The Node.js-app is the name of the image. So our image is named Node.js-app. And then we are tagging it with a version 1.0. Now we would have to build this Docker file, this Docker image using the Docker file. So what it's saying is specifying the build context. So look inside your current directory, which is the Node.js Docker app. You will see a Docker file there, and then use that file to build your Docker image. So let's click on enter and then see the results. Okay, I'm having a permission denied, so I'm going to give it some permission. So let me go here and then give it a sudo. All right, so let's enter. Okay, so it's getting a version of my base image, which is Node.js from a Docker Hub. It's creating a working directory right now. And then it's now going to copy my package.json, which has all my dependencies to install the dependencies, and then now have my application containerized. So currently we are in step 7. Step 5, that is copying all our source code from our local directory into our containerized application. And then we exposing a port 3000 on the container. Okay, so we can see the results here, successfully tagged, successfully built, successfully tagged. So let's check if we have our Docker image. What's the command? You can do Docker images. Okay, let me add my sudo and then Docker images. Right, so from here we can see that we have our Node.js application or our Node.js image here, which is tag version 1.0. So our image has been built successfully. So I'm going to paste the command to run the container here and explain this command to you. Okay, so this is some default command that I have here. So let's go and then see what this command means. So the first thing that you need is docker run. That is telling Docker to run the image to start a container. And then -d means that we want to run the services in the background. And then we have a port mapping that we need to publish. So this 3000 colon 3000 is saying that we have on our host machine, we've opened a port called 3000. That is where our application was running locally. Now, in our Docker file, we are exposing a port, another port called 3000. This is the port that we are opening on our container. So what we are doing is that we want to connect the ports on our local machine to the ports on our container, right? So that any request that is made to localhost, blah, 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 colon 3000 will now go to our container port for us to access our application. And then want to give our container a name. So you're going to use the dash dash name to do it. The name we are giving to our container is my app. I'm just going to change this name to Node.js app, maybe Node app. Right, so Node app. And then we need to specify the image that we are going to use. Our image is Node.js dash app, and then there is a version. So I'm going to add the version 1.0 to it. So let's click on enter. Oops. So I need to add my sudo. Okay, so I'm going to add my sudo here. Go to the end, click on enter. All right, so now let's verify if our container is running or has started successfully. So to do that, you need Docker PS to check all running container in your system. So I'm just going to do a sudo here and then Docker and then PS. So it's checking all running processes in our on our server, right? So I click on enter here and then I can verify from here that we have a container ID here and an image name, which is the Node.js app version 1.0. And then we have our container started that has been created about a minute ago, right? So we can now access our application from our EC2 instance. Let's verify. So let's verify if our application is running HTTP, and then we'll need our server IP, right, which I'm pasting over here, and then we'll need to go to a specific port that we set, which is port 3000. Okay, so once I click on enter, then you see hello from Docker. So this verifies that we've containerized our application and our application is running successfully. So we've successfully containerized our Node.js application. Now let's recap. What we've done is that we've taken the dependencies, the source code, and everything that this application needs to run, and then we've posing it into an image called a Docker image. Now we can give this Docker image to any of our team members, and our team members can run this Docker image to start a container, and our application is going to run inside that container, which is in Docker. Now, one of the key skills you need to own as a DevOps engineer's troubleshooting. So let's look at some common troubleshooting and steps. The first problem is if the browser does not load properly, then it means that the port is not accessible. So the first thing that you can do is to go to your EC2 instance and then look at the security group and then ensure that you've allowed port 3000. So allow connection to a port 3000 so that the browser can now load and ensure your Node.js application. The second problem that you may encounter is when your container stops immediately. So what you need to do is to check your logs. So there's a command that helps you do that using Docker logs, and then you specify the name of your container. So in this case, it's going to become node-app. That was the name of our container. So this helps identify any application errors by checking the logs. Then problem number three is when you are having Docker permission denied issue, like how you saw in some of my demonstration, because I'm on an EC2 instance and I'm running Docker commands. The instance was not allowing me to do that. So to solve that, I need to now use sudo and then add my command to be able to bypass that issue. Now let's summarize what we've learned today. So today we've learned how Docker works. We've talked about how containerization even started in the first place by seeing how to solve the box shipping problem that we had for moving goods piece by piece from the cargo into another transportation system and the problem that it can cause. And then we look at how we can now containerize this application or this goods. So instead of moving these goods piece by piece, everything is put inside a container, and now this container can be moved onto any other transportation system, and everything is intact. Then we talked about how Docker works. We learned how to create a Docker file. We know that the Docker file contains step-by-step instructions on how to build your image. So from the Docker file, we run a command to build our image that looks at the file, the instructions in the file, and then build our image. Now from the image, we can run our container. So we say Docker run, then we specify the name of the image, and then our container will be up. So we can now access our container by going to the IP address of our instance, and then we'll specify the port that we're exposing. In our case, was port 3000. Then your application is accessible. Now we know how to deploy a Node.js application using Docker. Thank you very much for watching, and let me know if you need any further explanation on any of the concepts or the next project that you would want me to demonstrate. See you next time. Take care.